Okay, in this video we're going to talk about how to measure DC current in an electric circuit. First, you'll start with the 6.5 digital multimeter that you see right here. Turn it on. And notice here we have, it won't set up the current just yet. Notice here you have a red connecting lead that goes into the I terminal and a black connecting lead going into the LO, the low terminal. At the ends of these leads we have alligator clips on both sides. These are going to connect directly into the electric circuit. Right here we have two resistors in parallel, and they are in, that combination is in series with an LED, and the LED you see is lit. And we have a power supply. It's supplying 10 volts and about 57 milliamps total. When it gets started, since we're going to break connections and need to break connections to to measure amperage, you need to turn the output off. So you press the output on/off button. I'm going to measure, and then we'll go over here. Let's measure the current in this resistor right here. What you do is you pull out one side. I'm going to put this back in place, the same location. Pull out one terminal like this and stick the resistor straight up in the air. Then take a small wire like this and put it back in the same exact location the resistor was, and put it up vertical like this. The blue wire is connected to the positive side right here, the positive side of the power supply. So we're going to take the alligator clip, the red alligator clip, which is a positive, and connect that to that blue wire like you see right here. And take the black alligator clip and connect it to the resistor just like that. So notice I've broken the circuit. That's how you have to do to measure amps, measure current. Right now the LED is not lit because the power's not on, so we go back to power supply, turn it on. We have power. We go back to the power supply and we need to measure DC amps. You see that blue DCI above the DC volts. So what we do is press the shift key and DCI, and there's your current. It's about 28.57 milliamps. Okay, to measure current in the other resistor, we need to break the connection. Before we do that, let's turn off the power supply. So we see output off. And we're going to put the other resistor back in place. Like that, and we're going to pull up the lead of one of the other resistors. It doesn't matter whether we pull up the top or the bottom lead, just happen to do the top lead. For this one, you take the wire and put it back in its place. Again, the exact same location it used to be on the same row that's powering the 10 volts coming in. And between these two connections, right here and here, that's where we're going to connect the ammeter. To the blue side, we'll connect the positive alligator clip. To the resistor, we'll connect the negative side. Okay, just like that. Oops, don't want to make the wires, gotta be careful, you don't want to make the wires touch, so I'm gonna lay that down there and there. Okay, there you see, it's hard to see this. Let's move this over here. See a little bit better. There, you have the connections set up correctly. I'm going to follow this. This red wire goes back to the ammeter, and the black wire also goes to the ammeter. Right now we have 0 amps. Why? Because the power is off. So press the output on/off button. We have volts in total current, and we go to the ammeter, and there's a current in the second resistor, about 28.3 milliamps. Sometimes it takes time for the amperage to settle because the devices are slowly heating up as you drive current through it, so it actually might take about a minute to get an accurate fixed current. So it looks like it's settling on about 28.2 milliamps. like to measure the current in the LED itself, so we will, first we turn off the power supply, connect the resistor back in place, like that, and we pull one of the legs up on the LED, and we put the blue wire back in its place where the LED used to be. Okay, put it back in that same location. It's connected to the positive. Again, the high side connects to the positive of the lead. We'll call this the low side because it connects back to the negative you see right there. That connects to the blue strip back to the negative of the power supply. So that's convention. If you do it opposite, you're going to see a negative on the meter. Okay, there's a connection. Everything's off, so we go back to the power supply. Turn the power supply on. You got power. Circuit's lit. And we have about 55.9. Close to 55.9 milliamps going through that circuit. That matches very closely with what the ammeter says itself. If you think about this circuit that we have, the total current going through this circuit goes through this orange wire, gets split up into the path of these two resistors, joins together, and all the current goes through goes through the ammeter and back again like this into the LED and through this black strip back to the power supply itself. So whatever's coming from the power supply must be the same as what's coming back. So that's why the current you see there, the 55 milliamps here, matches with the 55 milliamps you see there. The ammeter right here is actually the more accurate of the two, because you notice, you see, this is only 3 digits, where this is a six digit accuracy on the mil multimeter. So that would be that's what I would use for the current in the circuit. So in summary, to make any ammeter current measurement, you need to break the circuit. You need to break the circuit to make the connection. Be sure that you must have to do that. If I were to connect the circuit back up, you would actually short out the ammeter and it wouldn't read anything. So that's how you connect. That's how you measure amps.